This is the first lesson on geometric sequences. Okay, I guess the way I'll introduce this is just look at a few sequences and we'll see if we can complete their missing terms. So let's look at this first sequence. 1, 3, 5, 7, 9. Okay, you should be able to hopefully guess that the next term is 11. Okay, so in a sequence there's many terms. And the pattern, you can write it in your own words. I'd say add 2 each time. Okay, pretty straightforward. Okay, what about the next one? 1, 4, 9, 16. Hopefully we recognize these as square numbers. Okay, the next square number is 25. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay, the pattern is they're square numbers. Okay, or you can think of it as adding the odd numbers to it. Okay, either way, whatever. Okay, this last one, let's have a look. What's happening? 3, 6, 12, 24. Hopefully you get 48 from here. Okay, since the pattern in words is multiply by 2 each time. Okay, this last sequence is the one that we're interested in. Okay, called geometric sequence. Okay, I'll highlight that. Geometric sequence. Okay, and that's the focus of, I guess, the next few lessons and mainly this unit. So the idea is that the terms are T1, T2, T3, etc. as we go on. Okay, there's no T0. Okay, we start at T1. The first term is A, and the common ratio is R. Okay, common ratio being what we're multiplying by each time. Okay, so in this circumstance, A equals 3, R equals 2. Okay, just to help us set up the formula. Okay, these top two ones we're not too interested in. Just FYI, this is an arithmetic sequence. Okay, since we're adding each time, geometric sequences are where we multiply each time. Alright, so this table down here is just to get us an idea of how we're going to generate formulas for this. Our goal is to be able to, for this pattern that we just looked at, is to be able to just calculate, say, what's the 700th term in the series, or when does the series get to, in the sequence, when does the what term in the sequence is 20 million? Okay, to be able to do that without sitting in your calculator and typing in the values all the time. Okay, so we had these terms, 3, 6, 12, 24, etc. Okay, the term numbers, so this is T1, this is T2, this is T3, this is T4. Okay, and in terms of this idea of A and R for our geometric series, this first term is A. Okay, and then to get the second term, we'll multiply that first term by R. So we'll take this first term and multiply by R. To get the third term, so here, multiply by R. To get the third term, we'll multiply by R again. That was supposed to be an R. Still not very good. Okay, and we'll get AR squared. Okay, AR times R. AR 1 plus 1 is 2. Sweet. Okay, to get T4, I should have zoomed in on this. To get T4, again, we'll multiply by R and get AR cubed. Okay, so in general, to get the nth term in the series, in the sequence, which should be sequence as well. We'll look at series in the next lesson. Let's have a look at the pattern here. So to get the fourth term, take the first term times R cubed. To get the third term, the first term times R squared. We should be able to see that to get the nth term, we'll take the first term and then times it by R to the power n minus 1. And you can see how it works for the other terms as well. The power here is always 1 less than the term number. Okay, and so this thing that we just developed, we put in a big box since we're going to be using it all the time, okay, every day. All right. Okay, so let's have a look at an example. Okay, to use some of these ideas. Okay, we've got a sequence. For the sequence 2, 6, 18, 54 is the sequence geometric. Okay, for a sequence to be geometric, we need to have the same thing we're multiplying by each time. Okay, we don't want to just show times 3, times 3, times 3. Okay, that looks pretty amateur. Okay, to show that something's geometric, we need to show that the ratio of the successive terms is always the same. So I'll take T2 divided by T1. Actually, I should probably do part B first. What's the value of T1? T1 is 2. What's the value of T2? T2 is 6. What's the value of T3? T3 is 18. Okay, I need to show that this ratio is always the same. So to find the thing we're multiplying by, take the second term divided by the first term. So 6 divided by 2 gives me 3. And check that it's the same for the next two terms as well. The 18 divided by 6 is 3, yeah. And check that it's the same for the last two terms as well. Yeah. Okay, so we can say the common ratio is 3 between successive terms. That is sequence is geometric. Okay, if any of these were different, that weren't 3, then the sequence wouldn't be geometric. Okay, because it wouldn't have that same pattern between all of the terms. Okay, so our sequence is, remember, 2, 6, 18, 54. Alright, so it says find a rule, okay, using this general rule for the general term, which is the nth term, and use it to find T19, okay, the 19th term. Alright, so to find this general rule, I need two things. Okay, I need to find A, and I need to find R. I can find A pretty easy. A is just the first term, which I know is 2. Okay, I probably don't even need to have that in there. Okay, A equals 2, and just write some reason, since T1 is 2. Find R, I've already found it above. Oops. Found it above. I know that R equals 3. Okay, so my rule, I'm now going to use the rule. I can substitute in my value of A, which is 2, and my value of R, which is 3. Okay, and that's going to be my rule for finding terms, 2 times 3 to the power n minus 1. Okay, so this is very much like function notation. Yeah, it's very much like Tn, but instead of using that notation, we're just putting the term number as a subscript, as a small number. Okay, so let's just test that this works. Okay, it's always good to check your result. Let's find the fourth term. Okay, T4 will be 2 times 3 to the power 4 minus 1. Okay, and let's just make sure that we get 54. I say 2 times 3 to the power 4 minus 1. Your calculator's fancier than mine. I get 54, which is good. It asks me to find T19, so I don't need to write 19 terms out. Okay, T19 will be found just by substituting 19 in here. Should have chose a smaller example. 7748 40978 7748 40978. Just put commas in each 3, so I get 77 million. And I didn't have to do many calculations at all. Okay, I can just use that idea. Okay, from here, stop video, have a go at those questions. Yeah, hopefully you did well in those questions. Yeah, we'll look at some problem solving. So turn the page, we'll have a look at some basic problem solving, then set you free on some problem solving of your own. Okay, problem 1, in this geometric series, in this geometric sequence, 3, 6, 12, 24, which term has the value 2, 4, 5, 7, 6? Alright, so first of all, I need to find a general formula for this sequence. Okay, so we'll find the formula. Okay, or the rule. Okay, we could write the rule in words. We could say starts at 3 and multiply by 2 each time. That's fine, but you'd have to then multiply by 2 heaps of times to get 2, 4, 5, 7, 6, and remember how many there are, and what happens if you don't exactly get there. So it's better just to find the rule. Okay, so I know my formula is a times r to the n minus 1. Trying to find a, trying to find r. I know that a equals 3. Okay, since the first term is 3. To find r, I'm going to divide successive terms. Okay, and check that it works for the other ones as well. It's looking pretty good. Okay, so I can say r equals 2. Okay, and my rule will be the nth term is 3 times 2 to the power n minus 1. Okay, I want to know which term has a value of 2, 4, 5, 7, 6. Okay, so I'm going to sub in this term, okay, and find n. Okay, so into this rule, so when will my general term be equal to 2, 4, 7, 5, 6? Okay, I'm trying to find an unknown power here. I don't know that power, so I need to use logs. Okay, this is straight out of the exam that you just did. And divide it all by 3. Okay, and then I can convert this to a log statement. Okay, that unknown power will be the power that I raise 2 to in order to get 2, 4, 5, 7, 6 on 3. Okay, so the n that I'm after will be that log statement with 1 added to it. Okay, be careful with brackets. I get 14. Okay, so we can say the 14th term is 2, 4, 5, 7, 6. Okay, if I wanted to justify my answer, how could I check it? I could say to check, I could find what T14 is and just put that into my rule. Okay, and hopefully I get 2, 4, 5, 7, 6. Okay, just to justify your answer. Good communication justification. Alright, which term will exceed a million? Okay, so pretty much the same problem as before. I'm going to sub in general term of a million and see what n value, what term that will be. I'll sub it in just as per usual. Solve as per usual, dividing all by 3. Okay, convert to log. And then I'm going to add 1. This should be routine by now. If you're amazed by this solving using logs, you shouldn't be. It should be like taking a dog for a walk. And 19.35. Okay, we can't have 19.35 terms. Okay, remember I'd have T19 and then T20. Okay, I can't go sort of in between these. So I'm gonna have to do some rounding here. Okay, I know that I'm gonna need to round up here. Okay, I'm not gonna be able to round down to 19. Okay, because the sequence is increasing. Okay, the 20th term will exceed 1 million. Okay, because the sequence is increasing. Okay, we know that T19 will be under 1 million. Okay, and you can test that by finding what T19 is, okay, subbing 19 into that formula. All right. A second problem before you get set free into the wilderness and you can go outside and play. The second term of geometric sequence is 2, and the fourth term is 8. Find the third term. Okay, so I've got these terms. Second term is 2. Fourth term is 8. Okay, it's a geometric sequence. I'm multiplying by the same thing. A lot of people will just, in this problem, go, alright, must be like this. 4 is my answer. See you later. No. Okay, you've actually only found half of the solutions. Okay, and how are you going to do this if I say the second term is 5, the 5,000th term is 1,000,000.76. Find the 67th term. Any ideas? No, good. Okay, so you need to be able to do things completely generally, even though it's good that you can intuitively spot some of these solutions. All right, so let's try that again. Second term is 2, fourth term is 8. Find the third term. Okay, pretty much whenever we're trying to find a specific term, we always should be trying to find the general form first. Okay, if we can find the general formula, then we'll be able to find any term. We'll be able to find the millionth term. Okay, so our goal is to find the general rule. Okay, remember that Tn AR to the n minus 1, okay, for the sequence. What's the information that we have? I know that T2 equals 2, and I know that T4 equals 8. I don't know A. Okay, I don't know R. Some of you might think R must be 2. It has to be 2. Has to be 2. Okay, we'll see about that. Okay, so in terms of this T2, okay, from the formula, I know that I can find T2 by putting 2 in place of n. Okay, and I know that T4 I can find by putting 4 in place of n. Okay, so I've got these expressions for T2 and T4. Okay, but I know that T2 equals 2. So I can write that 2 is A times R. Okay, I'm going to call that equation 1. And I know that T4 is 8. And I'm going to call that equation 2. So I've got 2 equations here. And I'm going to try and solve these simultaneously. I could rearrange and use substitution. Yeah, if you want to use substitution, that's fine. Okay, you'd say A equals R on 2, and then put this in here. Okay, substitution styles. Okay, that'll work. Okay, an alternative when they're in this form is to divide the 2 equations. Okay, so I'm going to divide equation 2 by equation 1. Okay, and see what happens. So 8 divided by 2 equals AR cubed divided by AR. Okay, just dividing the 2 sides of the equation. 8 divided by 2 is 4. Index laws, cancel. R to the power 3 minus 1, R squared. Okay, so R squared equals 4, R equals 2. No. Okay, R equals plus or minus square root of 4. R can be plus or minus 2. So I've got 2 possible R values here. Okay, R is positive 2 or R is negative 2. Okay, so I'm going to find the A values. Okay, I've really got 2 streams here. So I've got R equals 2 and R equals minus 2. Okay, remember A and R don't always need to be positive. Okay, so if R is positive 2, I'm going to sub R equals 2 into equation 1. So 2 equals A times 2. Okay, I'm subbing in over here. Okay, I get A equals 1. Okay, so my general rule is Tn equals 1 times 2 to the power 2n minus 1. Okay, if R equals minus 2, I'm going to do the same thing. So minus 2 equals, okay, 2 equals A times minus 2. I'll get A equals minus 1. Okay, so in this situation, my rule is minus 1 times minus 2 to the power n minus 1. What was I asked to find? Find the third term. So on this side, T3 is 1 times 2 to the power 3 minus 1. Okay, which will get me my 4. Okay, in which case my sequence would be 1, 2, 4, 8, etc. Okay, in the negative side, I'm going to find T3. So T3 is minus 1 times minus 2 to the power 3 minus 1. Okay, we can put this in our calculator if we want. We'll end up getting minus 4. So our sequence in this half would be minus 1, 2, minus 4, 8. Okay, so find the third term. The third term could be 4 or minus 4. Okay, and that's the reason why we can possibly get 2 solutions. How we get these questions, just a hint for some of these. Okay, the hint is if I've got like r to the power 4 equals 1, okay, r would be plus or minus the 4th root of 1. Okay, but if I had r to the power 5 equals 1, r would just be the 5th root of 1. Okay, so plus or minus for even powers only. And you can think about why that's the case with squares and cubes. You're going to do these in class. Hopefully you get some good guidance and wisdom. Okay. All right, enjoy. Bye.